Hello, my name is Frank Kumar and I will be giving an introduction on this experiment. Point load test is used to identify the point load strength index and to calculate the unconfined compressive strength. This is done by doing a quick clipper test on core rock specimens and irregular rock fragments. This test can be divided into three types, which are diametral, axial, and irregular lump according to the specimen geometry. In this experiment, we need to measure the failure load P and the distance between plates D to calculate the uncorrected point load strength, which is P divided by D square. The correction is applied to account for the specimen size and shape. The unconfined compressive strength is obtained from correlation equation. Theoretically, before this, the point load strength test was widely used to measure the unaxial compressive strength and then became the standard test for general purpose of rock strength classification. The properties of point load strength test, such as more reliable and easier to measure, made the point load strength test mostly replace the unaxial compressive strength in the modern civilization. IS-50 is suggested to be used directly for rock classification to correct the short of unaxial compressive strength, which the unaxial compressive strength is only an estimated value.
Hi everyone, my name is Muhammad Sufi Alif bin Sulaiman. Today I would like to talk about what is point load test. Point load test is something we will do on site to test the rock strength. What we will do is we will put the rock sample between the conical platen and we will slowly increase the load until failure occurs. Point load test is very cheap and we can do it on site. Before I go into details about how to do the measurement, first let me briefly explain to you guys about this machine. First, in the normal PLT apparatus, we will have the load indicator. It will show you how much force that have applied onto the rock sample. Then this is the conical platen where the rock sample will be held. Inside here, this is the hydraulic piston. We can increase the length by pumping the hand pump. As we do the action, the hydraulic will flow from the hand pump to the hydraulic piston and the length will increase. This is how we increase the load in kilonewton onto the rock sample. This is where I would usually do the measurement before putting the rock sample to the PLT machine for testing. As we can see from here, this is a very beautiful rock sample. The rock samples could vary in size and shape. There is a recommended size. According to ASTM D5731, the dimension of the rock should never exceed 85 mm. It should be between 30 mm to 85 mm. For test 1, this is the rock sample that we are using. The depth that I will be measuring will be here, which is 24.62 mm. Then the width is perpendicular to the depth will be here. It is 32.0 mm. This is the first piece. The second width will be at the bottom, which is 31.98 mm. After measuring, we will record it. Then we will take the rock sample to the PLT machine and we will be testing it out. We will have to put the rock sample in between the conical platen right until it touches the rock sample. As you can see, the hand pump is hanging. That is because if we continue to pump it, we will have started increasing the load and apply pressure on the rock sample. So right now, what we have to do is to erase the zero error. In the usual PLT apparatus, there is a load indicator. Here we should remove the zero error. Then we will slowly increase the pressure to the rock sample. As we slowly increase the load indicator will also show an increase in value. After we subject the rock sample under pressure until failure, we will record down the load that we have applied to the rock sample. Then we will use a series of formula to determine the IS-50 point load test index of the rock samples.
Hello, my name is Chen Li Jing. Now I will simply explain how to do the calculation in this experiment. To do the tabulation and analysis on our data, we need to do some calculation on it. In the following step, I will use test 1 as an example of calculation. First, we need to calculate the average of width in this experiment. We sum up width 1 and width 2 and divide by 2 to get the average. Next, we need to calculate the cross-sectional area of our sample in this experiment. We multiply the average width and the diameter to get the cross-sectional area. The third calculation step is we need to calculate the equivalent chord diameter. We multiply the cross-sectional area in previous step we calculate with 4 and divide by pi, and we can get the equivalent chord diameter. The fourth calculation step is we need to calculate the size correction factor. We just substitute the equivalent chord diameter we calculate just now to get the size correction factor by using the equation in our theory. The last second step is we need to calculate the uncorrected point root strength. Is also same as the previous size correction factor. We just substitute the value we get from the previous calculation to get the point root strength. And last step of calculation, we need to calculate the point root strength. And finally, we can get 6.4954 Newton per millimeter square is the point root strength for our sample 1. That's all from our group 2. Thank you.